Okay, good evening, class. So today we are going to look at the solar system. So we are going to start with the introduction part of it. So the sun, moons, and stars are commonly referred to as heavenly bodies. The earth, the heavenly bodies, and the sky make up the universe. Also, the universe has stars, and a cluster of stars is known as a galaxy, which each containing many stars. And our galaxy in which the solar system exists is the Milky Way. So those are basic terms that you should know. So under the solar system, which is our topic 1, the solar system refers to the grouping of heavenly bodies comprising the sun and 9 planets. The sun is a star around which the planets and other heavenly bodies revolve. The solar system comprises the sun and the objects that orbit it, where they orbit it directly or orbiting other objects that orbit the sun directly. The largest 8 are the planets that form the planetary system. The solar system formed 4.6 billion years ago from gravitational collapse of a giant molecular cloud. The vast majority of the system's mass is the sun, with the remaining contained Jupiter. The 4 smaller inner planets, which are the Mercury, Venus, Earth, and Mars, are also called the terrestrial planet, are primarily composed of rocks and metal. The 4 outer planets, the giant planet, are substantially more massive than the terrestrials. Then we also have the 2 largest gases, which are the Jupiter and Saturn, are composed mainly of hydrogen and helium. The other outer 2 most planets, the ice giants, which are Uranus and Neptune, are composed largely of substances with relatively high melting points compared with hydrogen and helium called ices such as water, ammonia, and methane. The solar system also contains regions populated by smaller objects. The asteroid belt, which lies between Mars and Jupiter, mostly contain objects composed of rock and metal, like the terrestrial planets. Beyond Neptune's orbit lies the Kuiper belt and scattered disk-linked population of Transnepotonia, objects composed mostly of ices within these populations and several dozen to make more than 10,000 objects that may be large enough to have been rounded by the gravity. Such objects are referred as dwarf planets. You should also know that our solar system is located in the Orion arm of the Milky Way galaxy. There are most likely billions of solar systems in our galaxy. Then we should know how the solar system forms. Our solar system evolved from a thick cloud of interstellar gas and dust more than some 4.5 billion years ago. The cloud imploded probably as a result of the shockwave from a nearly exploding star known as the supernova. When this dust cloud disintegrated, it created a solar nebula, which is spinning, swirling disk of material. Gravity drew more and more material into the center. The pressure in the core eventually became so high that the hydrogen atoms began to combine and produce helium, therefore unleashing enormous amounts of energy. Our sun was born as a result, and it eventually accumulated more than 99% of the accessible matter. Further out in the disk, matter was also clumping together. These clusters collided and grew into larger and larger objects. Some of them got large enough for the gravitational pull to form, then into spheres, giving rise to planets, dwarf planets, and massive moons. So the composition of the solar system, the order and arrangement of our solar planets and other things is attributable to how the solar system evolved. When the solar system was young, only stony materials could resist the heat. As a result, the first 4 planets are terrestrial planets, which are Mercury, Venus, Earth, and Mars. They are all small and have rough surfaces. Meanwhile, components were we are accustomed to viewing as ice, liquid, or gas settled in the young solar system outer regions. Gravity drew these components together, resulting in the gas giants Jupiter and Saturn, as well as the ice giants, which are Uranus and Neptune. And the sun is home to 99.85% of all stuff in the solar system. Jupiter has more matter than all other planets combined. Okay. Our next one, the list below shows the mass distribution in our solar system, where we have the sun, planets, comets, satellites, and minor planets, as you can see. Okay. It contains many types of energy, as well as at least 2 solid components: interplanetary dust and interplanetary gas. Microscopic solid particles make up interplanetary dust. Okay. So we have other objects in the solar system, such as the asteroids, the meteorites, the satellites. So the asteroids are rocky and metabolic objects that orbit the sun, but aren't large enough to be termed as planets. Then the meteorites, aside from the asteroids, the sun is orbited by smaller rocks and dust particles. These particles of rock or dust make their way into the atmosphere. Then lastly, we have the sun. Our solar system largest object is the sun, and it is roughly 109 times the size of the Earth. The sun is a star with a surface temperature of 60,000 degrees Celsius, and it is largely made up of hydrogen gas with a minor quantity of helium thrown in for a good measure. The sun is the solar system's closest sun, and it belongs to the Milky Way galaxy, and it's thought to be more than 4 billion years old. So the sun is a yellow dwarf, medium-sized star, and as it rotates the galaxy, the sun spins gently on its axis. Solar flares are largely energy bursts that occur on the sun, and above the photosphere, there are 2 layers of gas termed as the chromosphere and corona. So the sun energy reaches the Earth and other planets in all directions. The planet absorbs less energy as it gets further from the sun. So make sure you do the assignments and the quiz that I've put in the